Okay, we'll be discussing in this video one of the models of population, logistic growth. Last time I discussed exponential growth for uh, population models. Now let me define what logistic growth is. It follows the differential equation dy dt equals ky times quantity 1 minus y over a, where y is the amount present at time t. Capital A is the carrying capacity. K is some constant that is positive since the population or whatever quantity in consideration is growing or increasing. And B is given by the formula A minus y naught all over y naught, where y naught is the initial amount present at the beginning of time, that is times equals 0. Now we won't show the derivation of the solution to this differential equation. It's already given there on your screens. If this is true, then the solution to this differential equation, given the initial conditions here, is y equals a all over 1 plus b e to the negative kt. So let's have an example. Let's read the problem. Suppose y is the number of people who have heard a rumor after t minutes, where y follows the differential equation dy dt equals ky times quantity 1 minus y over 10,000. And only one person knows the rumor initially, while 288 know the rumor after 10 minutes. Let's solve for the differential equation. Let's solve the differential equation there, and y in terms of t. That will give the number of people who have heard the rumor after t minutes. Now, in the equation given, a is the constant under y in the expression inside the parentheses. And in fact, this 10,000 here represents the maximum number of people in that community. So there are actually 10,000 people in that community. That's the carrying capacity. Now, why not is set to 1 since only one person knows the rumor initially, that is at time equals 0, meaning when t is 0, y is 1. Then after 10 minutes, 288 know the rumor, so we set y at 10 equals 288. And then, according to the formula, b is equal to a minus y naught over y naught. So we can solve for b. 10,000 minus 1 over 1, which is 9,999. And therefore, we can write down the solution to the differential equation. Okay, given by, okay, let me show that again. Given by this. Okay, once you know A, B, and K, you can write down the solution to the differential equation. We just need to solve for K, by the way. So we have this one, y equals 10,000 over 1 plus 9,999 e to the negative kt, k yet to be solved. but we are given y at 10 equals 288. So we use that to solve for k when y is 10, or when t is 10, y is 288. So we substitute those values and solve for k. So we get half this equation, which we can rewrite as follows. Okay, by cross multiplication, we have this equivalent equation, which in which we can isolate k, and thus getting e to the negative 10k approximately equal to 0.00337. Just transpose 1, then divide by 9,999 and approximate to the number of decimal places required. And then you solve for k by taking the logarithm of both sides. You'll be getting this one, then dividing by negative 10, we get k approximately 0.570, which we can plug into the differential, or the solution to the differential equation, thus getting y equal to 10,000 over 1 plus 9,999 e to the negative 0.57 t, which gives us the number of people who will have heard the rumor after t minutes. So if you are asked, for example, the number of people who will have heard the rumor after, let's say, 100 minutes, then all you have to do is plug in t equals 100 here and solve for y. But we will do that in the next example. Let's read the problem. An epidemic spread through a community so that 3 weeks after its outbreak, the number of people who have been infected is given by a function of this form. F of t equals a over 1 plus b e to the negative kt. Now, note here that the differential equation is not given, rather you are given the form already. Okay, the model that represents the number of people who have been infected at time t, where a here is the number of residents susceptible to the disease. That would be the carrying capacity. Might not really represent the whole population, but only those susceptible to the disease. Some might be immune. If 20% of them were infected initially and half of them by the end of the 4th week, what percentage of the susceptible residents will have been infected by the end of the 8th week? That's all. So we are told that 20% were infected initially. We're not given A, but we can represent that by 20% of A, which is 0.28. That would be our Y naught. Okay, the initial condition. At time 0, the number of infected persons is 20% of A. Then solve for B in terms of A. This is the formula, A minus Y naught over Y naught. Plug in 0.2A for Y naught and simplify. A will cancel out. You get 4. And so we can write the model as f of t equals a all over 1 plus 4 e to the negative k t, since we already got b, which is 4. So it remains to find k. A is not really needed to answer this problem. So we just solve for k, and we are told that, okay, in the problem, okay, sorry. The question is half of them by the end of the 4th week. So 50% after t equals 4. We will be using that to solve for K first. So there. So after 4 weeks, F of 4, 50% of those susceptible to disease were infected. So that's 0.5A. So we set the left-hand side to 0.5A and solve for K. Set T equals 4 here. So we have this equation. We cross multiply. A will cancel out, giving us this equation 1 plus 4 e to the negative 4k equals 2, which we can solve for k by isolating k, giving us this 2 minus 1 and then divided by 4.25. Take the ln, solve for k. Approximate to the required number of decimal places, in this case 3.347. And we can use that, put that into the formula, giving us this, k for k. So let's answer the question. How many will have been infected by the 8th week? So you just plug in t equals 8 into the formula here. So t equals 8 here. And then you can just evaluate the denominator. That's a number. And take the reciprocal of that times a. You'll be getting approximately 0.80 a. Now we don't know a, but we do know that 80% of that of the susceptible number of residents would have been infected by the end of the 8th week. So that's it for this session. There's only one participant, our Bidel. So Christian, do you have any question? So, okay, none. Just tell them that the quizzes and the graded exercises will always be manually checked. So they did not ask. Okay, so I'll end this session.